Hi everyone. So this PowerPoint or lesson will be on carbohydrates, which is the beginning of core topic 1. So essential nutrients are classified as nutrients that are required to maintain life, and we have several different macronutrients that can be sources of energy. The first one, which are carbohydrates, are the ones that we're going to be looking at today. They are 16 kilojoules per gram of energy. Another macronutrient is protein, which is 17 kilojoules per gram, and fats, which are 37 kilojoules per gram. Now, there is another nutrient or macronutrient, which is alcohol. However, alcohol is not essential and therefore it does not supply any other nutrients aside from energy and is therefore not considered to be an essential nutrient. We have other nutrients that are required for essential body processes, and they include what we call micronutrients. So these include your vitamins and minerals and are needed for growth as well as your metabolism. Another essential nutrient is water, which is about 60% of our body mass and is really essential for making sure that we can move fluid and our electrolytes around the body and also be able to excrete products as waste as well.
When I say the word carb, you probably picture bread, rice, and potatoes. And you'd be right. But you'd be just as right if fruits or vegetables or brown rice popped into your head. And you'd still be right if you thought of sugar or honey or jam or even a glass of milk. That's because lots of foods supply carbohydrate.
So you do need to know the basic molecules that make up carbohydrates, and those are carbon, hydrogen, and oxygen. So you do need to remember that. Now, when we talk about macro and micronutrients, the name might give away some idea of the quantities that you need. So for macronutrients, you actually need those in quite large quantities, and they have several roles. Their primary role is to provide energy. As I said before, carbohydrates have 16 kilojoules per gram. And what carbohydrates do is they provide all of the cells with glucose that is a primary fuel for all bodily functions. Their secondary role is actually the use of dietary fibre, which promotes digestion or digestive well-being.
Which of these has the least carbohydrates? This roll of bread, this bowl of rice, or this can of soda? Which of these has the... It's a trick question. Although they may differ in fats, vitamins, and other nutritional content, when it comes to carbs, they're pretty much the same. So what exactly does that mean for your diet? First of all, carbohydrate is the nutritional category for sugars and molecules that your body breaks down to make sugars. Carbohydrates can be simple or complex, depending on their structure. This is a simple sugar, or monosaccharide. Glucose, fructose, and galactose are all simple sugars. Link two of them together, and you've got a disaccharide, lactose, maltose, or sucrose. Complex carbohydrates, on the other hand, have 3 or more simple sugars strung together. Complex carbohydrates with 3 to 10 linked sugars are oligosaccharides. Those with more than 10 are polysaccharides. During digestion, your body breaks down those complex carbohydrates into their monosaccharide building blocks, which your cells can use for energy. So when you eat any carbohydrate-rich food, the sugar level in your blood, normally about a teaspoon, goes up, but your digestive tract doesn't respond to all carbohydrates the same. Consider starch and fiber, both polysaccharides, both derived from plants, both composed of hundreds to thousands of monosaccharides joined together, but they're joined together differently, and that changes the effect they have on your body. In starches, which plants mostly store for energy in roots and seeds, glucose molecules are joined together by alpha linkages, most of which can be easily cleaved by enzymes in your digestive tract. But in fiber, the bonds between monosaccharide molecules are beta bonds, which your body can't break down. Fiber can also trap some starches, preventing them from being cleaved, resulting in something called resistant starch. So foods high in starch, like crackers and white bread, are digested easily, quickly releasing a whole bunch of glucose into your blood, exactly what would happen if you drank something high in glucose, like soda.
Okay, so that video very nicely summarizes the different types of saccharides, your mono, disaccharides, and polysaccharides. So we have three different monosaccharides, glucose, galactose, and fructose, and they all have different their chemical formula is the same, but the way that the atoms are arranged are different. So you need to know the difference between the three of them. Now, disaccharides are a composition of two monosaccharides. So two glucose molecules will make a disaccharide, which is maltose. A glucose and fructose will make a sucrose molecule, and a glucose and a galactose molecule will make a disaccharide, which is lactose. Now, those three can be broken down by different enzymes, but we will talk about that more when we get to digestion. We then have oligosaccharides, which can be referred to as trisaccharides, but usually have molecules that are 3 to 10 in length. And raffinose is the main example of an oligosaccharide, which is glucose, fructose, and galactose. So raffinose is found mainly in molasses. So for example, it's used for making licorice, but has no dietary fibre. So then we've got our polysaccharides. And as the name suggests, they're made up of multiple molecules and they provide energy, fiber, vitamins, and minerals. So the main types of polysaccharides that you'll come across are starch, glycogen, and cellulose. So we have these two terms that we can break our carbohydrates into, simple carbohydrates and complex carbohydrates. So simple carbohydrates are made of one or two sugars and are absorbed quickly into our bloodstream. So sucrose and fructose are examples of simple carbohydrates and are broken down quickly, like the video just said. So lollies and soft drinks are really good examples of simple carbohydrates, and they provide a burst of energy over a short period of time. So other simple carbohydrates that are a bit healthier for you tend to include nutrients rather than just sugar. So milk, for example, is a simple carbohydrate, but it contains calcium. And fruit, for example, has fiber. So although they are still simple carbohydrates, they're probably better simple carbohydrates to consume rather than your lollies and soft drink. So complex carbohydrates, like the name suggests, are made up of 3 or more sugars, and they take longer to break down and digest than your simple carbohydrates. And what they do is they actually provide you with lower amounts of energy, but for a longer period of time. So examples of complex carbohydrates include bread, pasta, oatmeal, and rice, and vegetables like broccoli, corn, and legumes, such as kidney beans, chickpeas. So this is just a summary of your carbohydrates broken down into simple and complex, and then the examples. I would include this in your notes. So our food does have a density of nutrients to it relative to its food's energy value, as well as the amount of nutrients that it has apart from macronutrients. So nutrient-dense food tends to include a lot of different nutrients, so not only macronutrients, but micronutrients such as vitamins, minerals, and fiber. And they tend to have a relatively low kilojoule value. So examples of these are vegetables and fruit because they contain a lot more nutrients rather than just energy. So energy dense food includes high energy with a lack of nutrients. So carbohydrates are considered nutrient dense if they are high in vitamins, minerals, and fiber, but can also be considered energy dense if they're lower in fiber, higher in kilojoules, and usually high in sucrose with fewer micronutrients, so your vitamins and your minerals. So dietary fibre is another type of complex carbohydrate, and it's the ingestible part of plants, and it's found in unrefined or complex carbohydrates such as cereals or fruits, as well as vegetables and legumes. And it passes through the digestive system without much of a change. Its main role, though, is to keep the digestive system healthy to allow regular movement of food through the digestive system. So it is incredibly important for your digestive health. So some carbohydrates are available and they're considered or called available or soluble carbohydrates. And they include your pectins, gums, and mucilage, and they are completely digested. So their role is to actually help control blood sugar levels, and they form a gel in the stomach, and that slows emptying, which means it keeps you fuller for longer, so you don't feel as hungry as often. So really good food sources include oats, fruits, and vegetables. So often if you have oats for breakfast in the morning, you'll find that you won't actually be hungry until recess, if not lunch. So unavailable or insoluble carbohydrates are the carbohydrates that aren't broken down during the journey through the digestive system. And they include your cellulose, hemicellulose, and lignin. And they're not completely digested by the body. So fiber will provide a feeling of fullness that helps to prevent overeating. And a lot of whole grain cereals and seeds and nuts are really good sources of insoluble carbohydrates that help with that filling of the stomach to make sure that you don't eat too much food. So we talked about glucose before as being the end product of carbohydrate digestion. And glucose is really important because it's needed by all body tissues and is the preferred fuel for all cells. You can have protein and fat as other fuels, but glucose is the preferred fuel, and it's the only fuel for the brain as well. Excess glucose will be stored as glycogen in the liver and the muscles and can be broken down if there isn't enough glucose available in the bloodstream. And it can also be stored as excess body fat as well. So if after you consume a meal, your blood glucose level will rise. And what the pancreas will do is release insulin to stimulate glycogen formation, and that glucose will be converted into glycogen into the liver. And your blood glucose level will then fall back to its normal range. If, however, you have not enough glucose in your blood, the pancreas will be signaled to then start the breakdown of glycogen into glucose that's then released back into the bloodstream to then increase your blood glucose levels. So this is a series of events that result in homeostasis where you've got normal blood glucose levels. So your body can store enough glycogen for at least one day at rest or a few hours of exercise without having to consume anything. However, if you have a depletion of glycogen stores, then fat reserves will be used for energy. And as a last result, the body will use protein and convert that into glucose by breaking down muscles and other body proteins. And that's called muscle wasting. So a lot of well-trained athletes will store more glycogen in their muscles for extended periods of time for allowing exercise to occur. So when it comes to recommendations for how much carbohydrates you should eat or what types of carbohydrates you should eat cereals, breads that are preferably whole grain, as well as fruits and vegetables. And they are your complex carbohydrates. And you should be eating less of your processed or refined carbohydrates that have more kilojoules and less satiety, which is like they're less filling. And those are your simple carbohydrates. So the recommended carbohydrate intake in your daily diet is 45 to 65%, and only 10 to 15% of that should be simple carbohydrates. So some of the symptoms of excess carbohydrate consumption is dental caries or tooth decay, because carbohydrates, if they're from sucrose, what happens is if you've got bacteria here with the sucrose that then causes acid, that acid then interacts with the tooth and causes a cavity. Another symptom of carbohydrate excessive consumption is an increase in body fat, so your adipose tissue. So excess glucose is stored as body fat. And also if you have a lack of minerals and vitamins, mainly, and those can be mainly available from proteins and fats. So the other end of the scale is actually a deficiency in carbohydrates. So if you don't consume enough carbohydrates, you'll feel weak or fatigued or like you're going to faint. You might have nausea or headaches or a lack of ability to concentrate. So that's why it's really important that you actually have breakfast in the morning, because that breakfast provides you with some glucose so that your brain can actually function properly. You may also have a loss of appetite, or you might feel irritable. So hangry is actually a thing, and I know that quite a few people actually suffer from being hangry, and that's where you don't have enough energy and your body kind of goes into survival mode and you become quite irritable. And that's actually a self-preservation mechanism. If you don't have enough carbohydrates stored as or glucose stored as glycogen, a prolonged exercise will become more difficult because you don't have enough energy to provide your cells with to be able to function properly during that exercise. And if you don't have enough complex carbohydrate consumption, that will also lead to insufficient dietary fiber intake, which can result in constipation as well.